Hey everyone, just doing a quick video on graphing sine and cosine functions in Desmos. So the first thing that you'll do is go to desmos.com, go to their graphing calculator, and it'll bring up the usual. I'm assuming you've at least used a few of the options here before, but such as typing in equations to graph, things like that. But we'll go through a few other settings that are useful for trig functions. So first off, I'm just going to graph y is sine of x. A lot of times you can either do x, or sometimes you can even do theta if you just want to type in theta, right? I'll do y is sine of theta. Sometimes if you want to add other things like sliders, you can add sliders and modify stuff. So we'll talk about that kind of thing in a minute here. But the first thing, I'm just going to graph things with x. And the first thing you'll notice is that this is the usual, right, like negative 10 to 10, negative 6 to 6 grid that comes up on Desmos. All your tick marks are every 1 unit or half a unit if it's one of these minor ones. So you'll see major tick marks at 2, 4, 6, minor ones depending on your zoom level that may change, right? So if you zoom it out, sometimes that'll change. But sometimes maybe you want, right, like this point, right? Is it pi? We know some of these tick marks or interesting features on the graph are pi over 2, pi, 3 pi over 2, or some multiple of pi. So the first thing you can try is just changing your grid to accommodate that. So what you can do with the x-axis is change that step size to pi over 2 or pi over 4 or whatever you want in terms of pi, and it'll adjust. All right, so now I see, since I put in my step size as pi over 2, I have those tick marks every pi over 2. So pi over 2, pi, 3 pi over 2, 2 pi if I keep going, or the negative values, right? It'll keep going as far as you want it to, just labeling those grid marks every pi over 2 units. Notice the y did not change because I didn't change the y. You don't usually want to, but sometimes you do want to change those x tick marks to be in terms of pi. That's especially true if you're in radians, right? Not so much if you're in degrees, but if you're in radians, which we will be most of the time when we're graphing stuff, just because calculus works really well with radians. There's some things with degrees that get pretty annoying, so most of the time we're going to be in radians just because we want to get used to it before calculus 1. So if you're ever wondering, why are we even bothering with radians? Why don't we just do everything in degrees? That's generally why, is because calculus works much better with radians than it does with degrees. Okay, so if for any reason you did want to graph in degrees, right, there's this option where you can click degrees, and I'll change this step size, right, erase that, go back to that every 2 units. Right, so notice on this, right, it's going from 0 to like 20 degrees, which isn't very far. Need 360 to get a whole cycle. So if you do need degrees, you can always change, right, what your x is between. So I could say go between maybe negative 400 and 400. Right? That's not so much if you're in degrees. Or zoom out even more. So there's my sine function, right, which would complete 1 full cycle in 360 degrees, right? So that is the idea. Like I said, most of the time, though, we're going to be in radians. So, and I definitely don't want that. So a lot of times, just that standard kind of negative 10 to 10 type of window is fine. You'll probably adjust it by zooming in and out anyway, but I am going to change that step size. Right, so change that to pi over 2, and then I can see some of my features that are there. Now, like I said, you can always add stuff in. So if I want to change my amplitude, right, I can make that maybe a 4 sine x, and then I'll go up and down 4 from the midline, right, changes that amplitude. If I want to put in a 2x, right, inside that sine function, that'll change the period, right, so now it's moving twice as fast as it was before. And you can just modify whatever you want on there. If we put in something like this, I think I might have extra space there. If we want to shift, right, so maybe I want to shift this over by, let's say minus pi over 6. That'll give me my horizontal shift right over where now that value is starting at pi over 6. If I want to change the midline, I can always say add 2. That'll put it in. So graphing on Desmos is pretty easy. You just type in what you need. The only recommendation I usually have is just changing that x-axis so that your tick marks are in terms of pi or pi over 2 instead of the 0, 1, 2 normal type of scaling. The last thing I'll say, and we'll cover more of this in another video, is if you want to graph things like tangent or secant or stuff like that, especially say secant or cosecant, that sort of stuff. We can sneak peek what's coming up. So this is our sine function, right? I can kind of zoom in on that. And if I want to graph cosecant, I can just type it right in, CSC, and then the x. So that'll be the cosecant of x. Notice all the peaks and valleys kind of line up with sine. That's because cosecant is 1 over sine. So 1 over 1 is going to give you a 1. 1 over 0 is going to give you an asymptote. So it's not going to display the asymptotes, but you could always put some in if you wanted to. So that is kind of the general idea of graphing. You just basically type it in, see what pops up, and you're good to go. By just changing that x-axis, making sure you're in radians, and then changing the x-axis to units of pi is usually something that you'll want to make sure happens. All right, like I said, we'll talk about cosecant, secant, those in another video. On the calculator, you usually have to type in 1 over sine or 1 over cosine or things like that. But in Desmos, you can just type in the usual abbreviation. So, all right, we will see you on the next one.